Yeah, so I'm going to talk about BetterHash this evening. If you are coming to Advancing Bitcoin, don't worry. I'm talking about something completely different, so you're not going to get duplicated content, and that talk should be interesting as well, although admittedly I haven't written it yet, so we'll find out. So BetterHash is a project that unfortunately has some naming collisions, so might actually get renamed at some point, but that I've been working on for about a year to redo mining and the way it works in Bitcoin. So who feels like they're kind of familiar with how Stratum and pools and all that good stuff works in Bitcoin, kind of at a high level? Half and half? A little bit more than half. All right. So I'm going to go through a little bit of background. I can rush through it and skip it. It's kind of stolen from a talk I gave that was much less technical. So if you fall asleep for the first 10 minutes or so, that's going to be perfectly okay. But I wanted to kind of give a little bit more like philosophical background as well, right? So, Bitcoin didn't invent eCash. eCash as a concept is not new. It's been around since the 80s and 90s, and a ton of people were trying to do this at that time, and they all kind of failed. So who read the Ray Dillinger piece on LinkedIn? If you haven't read it, you should go back and read it because it was really good. Random guy claimed he was around back then, kind of in the 80s and 90s, claimed that he had seen Satoshi had mailed him the paper before the announcement. No material reason to disbelieve that claim, although it doesn't really matter. But he wrote a really good piece about kind of what it was like back then, working on eCash with all these startups in the Caribbean and trying to build, essentially trying to build Bitcoin, but failing. And out of this came a lot of kind of simple, centralized US dollar banks that just failed because their business models failed. Out of this came PayPal, which I guess we would consider to have failed in the censorship-resistant money case because, well, they had to succumb to regulators. Out of this came some attempts at eCash like Chaumian tokens, which were shut down because they were very usable as money laundering and got shut down by various regulators, especially in the US. But ultimately, they all failed kind of for the central reason that they were a centralized third party, right? So they had some business that could go under or fail or be targeted by regulators, and they all failed to live up to this goal. And so Ray, I think accurately, phrased Bitcoin as a novel attempt to solve this centralization problem, or solve this eCash problem by removing the centralized third party. And it was kind of the first real attempt someone came up with that it's realistic, this might actually work. We don't know that it's going to work yet, and that's why we're talking about mining and centralization in mining, but it's kind of experimental, and maybe we can actually achieve these goals that we've had for 30 years and haven't accomplished yet. So I'm sure a lot of you will recognize this. This is actually a number of months out of date, but that was, as of a number of months ago, the pool distribution and hash rate distribution for pools in Bitcoin. The top two are owned explicitly by the same company, so that should actually just kind of be one. That's Antpool and BTC.com, who are the same company, and in fact, they also run via BTC, which is one of these, so yeah, it's kind of bad, right? They clearly have a lot of control of hash power. When I gave this original talk, I phrased it as consensus group. I think this is actually kind of a really useful phrase when we're talking about cryptocurrencies broadly, because it's not just hash power, right? Ultimately, maybe it's stakers in a proof of stake system, maybe it's the 5 or 6 nodes who validate things in Ripple, whatever. Ultimately, your consensus group is like the people who are able to select transactions and put them in blocks or make them confirmed in some way. And in Bitcoin, that is obviously pools, right? So pools work by having this block template. They create the block template. They use probably Bitcoin Core. They get a list of transactions. They create this candidate block. They send it to all their clients, who then hash a bunch. If it matches a full block and it has enough proof of work to become a full Bitcoin block, gets sent back to the pool, and the pool will distribute it. If it has a lot of work but not enough, it still gets sent to the pool, and in fact, that's how they do payouts, right? Because if you have some probability that it will be a full Bitcoin block and 10x higher probability that it will be not a Bitcoin block, but sent to the pool anyway, you can still see how much work all of your clients are doing, and you can pay out based on that. You have a warning that you're on unsecure Wi-Fi. I'm going to ignore this.
Just turn the Wi-Fi off.
Nah, it's fine. Okay. I mean, unless you want to turn the Wi-Fi off.
We don't need the Wi-Fi.
Well, whatever. So Slush Pool actually has the public statistics for the breakdown of each of the individual users on their pool and how much hash rate they have. I blindly took that and mapped that onto the graph you saw earlier, and this is what I came up with. So this is what our goal is, to make Bitcoin look like this. Obviously, it's a oversimplification to the nth degree, but it was easy and it was the public stat that I had. There's reason to believe you have some larger miners on other pools, but even still, this is actually probably not entirely inaccurate, right? It is in fact the case that ownership of hardware and management of farms is way more decentralized than pools, right? Pools, your whole goal is to reduce this variance problem. If you are a 1% miner or a 0.5% miner or a 0.25% miner, some months you're not going to make your power bill, some months you're going to make a bunch more money, so you have to have a pool. And so naturally, there's a lot of centralization in that market, whereas in the actual hash rate market, purchasing cheap power is often more available in small quantities than large quantities, not to mention larger investments than a pool, blah, 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 and you actually see much better decentralization. So the goal is to get there. We do this by taking the kind of key observation that the consensus group in Bitcoin is the people selecting the transactions. That doesn't have to be the pool. The pool can still manage the payout, right? So the idea is we take all of the miners, we give them all full nodes, they select all the transactions, they have a mempool, they build the candidate blocks that they work on, and then they pay the pool. You still have centralized pools, but the only thing they're doing is receiving the payment for blocks that are full valid blocks, and then they can distribute that as they do normally, as they do today. They don't actually necessarily need to be involved in selecting the transactions and doing the kind of key consensus group things that we care about in Bitcoin. So there's obviously a number of problems with that that I'll get into, but first I'm gonna just kind of describe what the state is today and the high-level protocol design. So BetterHash is actually a replacement for two protocols. So currently there's kind of two main things that are used in the mining process today. There's Stratum, which you're probably, or more people are familiar with. This is the protocol that the pool server uses to communicate with the actual clients. It is a mess. Actually, get block templates also a mess, but Stratum has like it has 32, so it's JSON, and it's mostly hex sent over the wire in JSON, and it has things like 32-byte numbers that are sent as hex in JSON, byte swapped on 4-byte boundaries, because apparently no one knows how endianness works. It's confusing as shit. But it's...
Can you elaborate why you dislike JSON?
JSON is fine, but hex in JSON has all of the downsides of having a binary protocol, and that you can't read it on the wire anyway, because it's hex, and all of the downsides of being JSON and text because it's bigger and has more complex parsing and whatever. And remember, like most of these ultimately, the ASIC controllers are embedded devices. They're running like OpenWRT and some pretty crappy software. So you don't really want like a super complicated parser. They never get updated. So if you have a bug in your JSON parser, like all these things are vulnerable. It's like not ideal in that environment, especially. So the other current protocol is called Git block template. It is, in fact, just an RPC call on Bitcoin Core. It has a bunch of like bells and whistles that literally no one knows how to use and probably don't work because I'm pretty sure they don't get tested. But it is kind of the protocol with which the pool can, or the pool server can request data from the Bitcoin Core node about which transactions to send. It's also a mess. It sends you all of the transaction data, again, hex in JSON. Don't know why. It sends you all of the transaction data, like the full hex of each transaction that you want to include in the block, but you have no reason for that, right? So Stratum actually only sends you a Merkle path. So it sends you information you need to build the Coinbase, i.e. the first transaction, and then just hashes of the other pieces that you need to build the Merkle root. So it doesn't actually have to send you anything on the one side of the tree. Whereas Git block template, you in fact only want the same information, but it gives you not only the full tree, but all of the transaction data anyway, just to confuse you and make you do more work than you need to, which also makes it, of course, slower. The JSON serializer in Bitcoin Core is like fine, but it's not that fast. And if you're encoding a full 4 megabytes of like hex blobs into JSON, it's not that fast and has no reason to be that slow. It's also very kind of pool oriented, right? So it leaves a lot of complexity on the pool server. Instead of the kind of Bitcoin Core node being able to say like, hey, hi, I have some new transactions that you should include in your new block, or hi, I just got a new block here, you should start working on this now. It forces the pool server to think about these things and request that information from Bitcoin Core. It has some bells and whistles to try to not do that, but no one uses them. And we don't like this world. Bitcoin Core, obviously, in the node has more information than the pool server does because it has all the transactions. It knows when it just got another transaction with a really big fee on it that it wants to make sure you're mining on. It knows when you got a new block because it's the first thing to see it, blah, blah, blah. And so we'd like to have more kind of control over that in Bitcoin Core just because we can make better decisions and we can optimize that instead of making the pool guys optimize that, which is kind of a centralization pressure. We don't like a well-optimized pool shouldn't be a lot faster than a poorly optimized pool because that means they have to have technical competence and we'd rather them just be able to kind of spin it up and run it. Yeah, so that's kind of what's used now. Any questions on that?
So I don't know the history of it. Can you talk about the step from get work to get block template?
Yeah, so git work was a much older thing in Bitcoin Core that was used to get work. It did not, so it only gave you the header, so the 80-byte block header, which was fine for CPU mining and GPU mining, but that's actually too slow for an ASIC because you'd have to get a stream of those, like, what, millions of times a second? And so it's like vastly too slow for that. So a new thing had to be created, and git block template was added as like the thing to replace it. It's terrible, but someone had to write something, and so the first thing that was written got merged.
But so like git block template was never designed for pools?
There was some intention for that. I mean, yeah, there was some intention for it to be used as such, but it never made any sense because it's too much data too. Even in Stratum with the like weird hex encoded nonsense, if you get a work update, like for a new block, it still fits in a single TCP packet. Not by a ton, it's close, but it does. So that's nice for efficiency, whereas git block is like 4 megabyte, or but 2 megabytes of data minimum plus SegWit just to give you a new block template, like that's just nonsense.
Why do you think the design that way? Why do you think the America route that you mentioned? Why is it
the intention was for Git block template to be like, the pool would give you too much information and then the clients would do some like policy thing. Luke designed it. The intention was like that clients could do like policy around which transactions to include themselves. It never really made any sense, to be honest. All right, so BetterHash, I talk about it as 2 protocols. It's really 3 protocols, but whatever. So obviously it splits the lines a bit differently, right? Because we have, intention is that clients run full nodes and not just the pool. It splits the lines a little bit differently. So we have the work protocol, which is kind of that Merkle path, the current header, some basic information about how to build the Coinbase transaction, the previous block hash, those kinds of things. And the pool protocol, which is really just payout information. It's like, yeah, if you find here's how you submit shares, and if you find a block, it should pay out to this address. Then you use that to submit shares to prove that you're working and prove that you're paying out to the right address and blah, blah, blah. So there's I say it's kind of 3 protocols. The work protocol is used in kind of a few different contexts. It can either be kind of final or it can be non-final, where non-final means it doesn't have full payout information. If you start mining to a non-final work without adding a full payout, you're just going to burn all of the reward to nothing, which would obviously be kind of a shame. Final is here's all of the fully built thing, you can go mine on this. Right, so you can imagine in non-final mode, you need to connect to a pool or be solo mining. So you need to kind of combine that payout information you got from the pool, or you can be solo mining. Whereas in final mode, that's the thing that you pass to your ASIC and you go mine with that. There's kind of there's kind of a high-level goal of having a mining proxy in the farm, which you can think of as just kind of like a Raspberry Pi or a Casa HODL node kind of thing, where all of your devices can connect to that device, and then it can run your full node, it can connect to the pool, blah, blah, blah. You could, in theory, also skip that and have each of your ASICs actually connect to the pool and have them all connect to a full node, but that's up to you. And of course, for practicality reasons, because a number of miners aren't going to run their own full node, you could also have a pool expose your final work protocol version to clients who don't want to run their own full node, because that's just going to be how it works in practice a lot. Make sure I got everything. Yeah, so another interesting goal, ideally, we'd like to be able to just mine against Bitcoin Core. You shouldn't necessarily need a pool if you want to solo mine, or mostly for testnet, but also for fallback, right? So the work protocol being the thing that connects to your ASIC controller or to your ASIC, and is also the thing that Bitcoin Core speaks, is kind of nice, because now if the pool goes offline, or if you're testing, or if you just want to solo mine, you don't need anything else. You don't need, currently you need a pool server because no ASIC speaks Git block template. So you have to have some other software in between. And so now you don't necessarily need that. And if the pool goes offline, you can fall back to solo mining, at least until the pool comes back, which is kind of a nice little property. And actually, of course, I lied. There's 4 versions of this protocol. There's 2 variants of the work protocol. So who's kind of vaguely familiar with the Bitcoin block header format? Okay, some. It's 80 bytes. But the key observation is there's a 4-byte nonce, which is kind of the thing you're trying to work on. You increment the nonce, and then you test the hash, then you increment it again, you test the hash. There's also a 4-byte timestamp, and then there's a 4-byte version field. So if you just increment the nonce, you would run out very quickly on an ASIC. That was in fact the problem with git work that we mentioned earlier. It's just too slow. You run out of 4 bytes of 32 bits of nonces very quickly on a modern ASIC. So you really only need a few more bits. And so there's a proposal to use some of the bits in the version field, use 16 of the 32 bits in the version field. We don't really need that many bits in the version field as a secondary nonce location. And then you can cheat and you can spin 2 bytes of the version, 4 bytes of the nonce, and you won't run out within 1 second. And then every second you can increment the end time field. So you actually never need to give the ASIC device the Coinbase transaction, which is currently kind of really annoying because the ASIC is involved, like all of the end hardware in Bitcoin, or at least the ASIC controllers, which again, generally runs kind of crappy software that's not maintained, not updated, blah, 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 is involved in constructing the Coinbase transactions and building the whole Merkle path and has a lot of complexity. And so if we can get rid of a lot of that complexity so that we literally just give it 80 bytes and it knows that it can spin these 4 bytes, these 2 bytes, and it has to increment that one every second, it is like so much simpler and we can have a lot more flexibility in terms of protocol upgrades and that kind of thing.
How does this interact with ASIC boosts?
Yeah, so the current ASIC boost stuff actually uses the end version field, specifically those 2 bytes in the end version. Yeah. So the BetterHash spec references that and says like, yes, these 2 bytes that people have already been talking about using and are already using, just go ahead and say like, yes, use them.
It's the source of all those warnings we see on our nose, right?
Yeah. So I think the current ASIC boost stuff only uses like 2 bits, but there was a proposal that says like these 2 bytes should be the ones used for ASIC boost. So
Matt, do the ASICs currently tweak the Coinbase transaction then in order to get
Yeah. So they actually have. So the way Stratum gives you a Coinbase transaction is it gives you like a prefix. It tells you how many bytes you get, and it gives you a postfix. And you just append, you take the prefix, you add however many bytes, you can use that as a nonce, and then you add the postfix, and then you build the Merkle path.
But what is the postfix in reality? Some operator?
So the prefix and postfix are just parts of the transaction, and the part that you get to spin in the middle is in the script sig input. So it'll be like the very introductory, so like what the version, the number of inputs.
Not covered by any signatures. Well, obviously.
Yeah, not covered by signatures. Yeah, because the Coinbase transaction. So like the prefix will be like the transaction version, which is 4 bytes, the number of inputs, which will be 1, which is 1 byte, the length of the script, and then some like the pool's name and shit like that. And then you'll have like your 4 bytes that you get to play with, and then it'll be the rest of the script sig, the number of outputs on all the outputs as like a blob. Yeah, so we'd like to move to headers only. Of course, with this whole separation of like the work protocol versus the pool protocol, where the work protocol has to be able to support not having the payout information, we still have to support the non-header version. But ideally, at least like from an ASIC perspective, you can just do this header version that's just like 80 bytes and you don't have to have all this complexity. So some existing problems in the current world. So I kind of already went through Git block template. It's a complete mess. It also was really gnarly, like SegWit required updates to Git block template. And so we had to update all the pool servers for Git block template for SegWit support, which was like, there was just no reason for that. Like that shouldn't be how we had to do things. So Git block template needs to die. I'll be very happy to see it go. So I already talked about that a little bit. So Stratum is not authenticated at all. There's no crypto, there's no signatures, there's nothing. This is terrible.
How is that possible? I mean, if you're sending shares to a...
So if you're, so,
shares, or...
yeah, someone could, yeah, your ISP, like, there is,
surely it must be authenticated. You're telling me some
No, there's no authentication whatsoever. Like, I would not be so, like, if I ran an ISP in China, I'd be skimming a percent off the top, and no one would notice. Like, dead serious, no one would notice if all the ISPs in China are skimming a percent of the hash rate off the top, because like mining farm will vary in its hash rate, you know, a few percent in a day based on temperature and other nonsense.
You can wrap it in a SSL.
Yeah, some pools support wrapping it in SSL, but it depends on the pool.
It's not the majority for sure.
Yeah, it's not the majority, and it's like most of the ASICs don't support it, right?
I'm going to Dogecoin. I think this is.
Yeah. No, all the coins use Stratum. Dogecoin uses Stratum. Everything uses Stratum. Yeah, so this is a mess. And in fact, we saw a BGP hijack against altcoin pools in like 2012. And I'm not aware of one against Bitcoin pools, but we saw some against altcoin pools in like 2012 or 2013. So like we know this is a very practical attack and could like steal a ton of hash rate. It's made even worse. Yeah, I mean, they clearly should. And it's like a material risk too, because you can, Stratum has a wonderful message where you can say, hey, I, the pool server, am moving to a new host. Please connect over here. And then they have to power cycle all the hardware. So if you can like get a temporary man in the middle, you can get all the hardware to point to a new pool server for you. And then they have to power cycle their entire mining farm before it reconnects. It's like terrible. So like, don't be surprised if we see like massive 51% attacks for a day while people have to react and go like power cycle their hardware. It's like not an inconceivable attack. That said, you can't just trivially like encrypt the whole thing, because pool servers actually have relatively high server overhead. They're checking shares. Like the whole point of a pool is you get more shares. The lower the difficulty on the shares is, the more consistent the payouts, and that's what your users want. So they always tune to have very low share difficulty, which means more server CPU time just hashing all of the shares and making sure they're valid. So you can't just like blindly encrypt everything. So BetterHash is relatively carefully laid out with all the messages so that they're signed. There's actually no encryption, but they're just signed, so whatever. You can still see that someone's running BetterHash, but at least you can't modify it. But the messages are signed in such a way that the only messages which are signed are one-off messages or messages that get sent to all the clients, right? So when a pool wants to, like when a new user connects, the pool will sign a response like, yes, hi, I understand you are user A, and here's your payout information for you, user A. And then obviously the user can check that, make sure that that lines up with the username they are handing to the pool, but that only happens once on connection. The share submissions aren't signed because the pool told the user the payout information for that user, so it's self-authenticated already. There's no reason to add a signature to that just to slow down the pool. And also on the work protocol side, the updates, if you have like a new block update, that data itself, you just have to sign once and you can send that to all of your users. You don't have to sign a different copy for every user. And there's a separate message for per user data, just to avoid any complaints about server overhead for pools who might wish to deploy such a thing. Only byte flips in 34-byte boundaries. This isn't documented anywhere. I couldn't find anywhere that said this. I had to figure it out on my own. Like, there is no standard for Stratum. Good luck trying to re-implement this stuff. It's like nonsense. So BetterHash actually has a spec. I bothered to write it out. It's also incredibly dense. If you've ever tried to read any of my BIPs, they're dense as fuck. But it's very clear exactly what you should do. You just have to be good at parsing run-on sentences.
Bit number or?
Yeah, XXX. No, I haven't bothered to get it a BIP number yet. There's a few more tweaks I wanted to do, but
Is it public already?
yeah. There's a post on the mailing list, and there's a link actually in the meetup description to the current version on GitHub. Vendor messages. So there's a general trend right now. Pools, if you run a mining farm, like monitoring and management is actually really kind of a pain in the ass. There's one off-the-shelf solution I'm aware of. They charge you like a certain number of dollars per device. It's Windows only. It's like not a remote management thing. You have to be there, and it is like really bad. So like most farms end up rolling their own like management and monitoring software, which is terrible because most of them like are people who have cheap power. They're not necessarily technical people who know what they're doing. So like we want some extensibility there, but I'm also not going to like bake in all of the like, please tell me your current temperature kind of messages into the spec. So instead there's an explicit like extensibility thing where you can say, hi, this is a vendor message. Here's the type of message. Ignore it if you don't know what that means, but do something with it if you do. So that's all there. And that's actually really nice for pools, hopefully, and for clients. And I don't know why the hell you'd want this, but someone asked me to add this, so I did. I wrote up a little blurb on how you can use the vendor messages to make the header-only final work protocol go over UDP, because someone told me that they wanted to set up their farm to take the data from UDP broadcast UDP, so you don't have to have individual connections per device, and shove it blindly into the ASIC itself without an ASIC controller whatsoever. Again, I don't know why you'd want to do that, but if you do, and you're crazy, this is explicitly supported, and there's like a little write-up of how you might imagine doing such a completely insane thing. Yeah, so those are the existing problems. Now, of course, luckily, BetterHash being more fancy, it comes with its own problems that have to be solved if we want to get any kind of adoption. So first of all, I mean, operational complexities is kind of the obvious one. Again, like I mentioned, a lot of mining farm operators aren't necessarily the most technical people. Telling them, hi, you need to run a full node now is a steep barrier. Obviously I mentioned. So with that in mind, it is an explicitly supported thing that the clients don't necessarily have to run a full node. It's an option and strongly encouraged, and that's kind of the whole point. But if you don't, at least we get like authentication and standards and the other things that are nice. Yeah, I mean, there was a story. So the way current mining farms are often set up is you have like all these devices, you have like 1,000 devices, and they all connect to the pool. Like you configure all of them. So you have like 1,000 TCP connections from your farm that are all getting the exact same data from the same server at the same time. Anyway. And so some of the pools have designed these kind of little proxies that are simple little Raspberry Pis. You plug it in at the farm, and you point all your devices to that, and then that connects to the pool, and that connects upstream to the pool. And they had clients who were running very large farms who couldn't figure out how to do that. They couldn't figure out how to plug in a Raspberry Pi and reconfigure their miners. So yeah, some of these guys really don't know what they're doing. So with that in mind, if we're going to imagine a world where some of these guys who don't know what they're doing are going to run a full node, you can imagine how they might creatively misconfigure this and end up generating garbage or not uploading the blocks or ending up with like no mempool, so they have no transaction fees they're claiming. You can imagine how a user might deliberately misconfigure this. So we have to have this option for the pools to kind of spot check the work that's coming in. This, in fact, actually interacts with block propagation as well. Existing pools obviously have a lot of block propagation optimization that they've done, and when they're the ones creating the work, they have all the transactions. If a share comes in that is a full block, they have the full block. Whereas if you imagine sending just shares to the pool, where the client is the one who created the full block, well, the pool doesn't have the full block to broadcast. And of course, some of these farms are like behind random crappy DSL modems in rural China, so you can imagine block propagation might suffer. So with that in mind, the pool protocol actually has a weak blocks protocol built in. We can finally actually do weak blocks because no one's ever bothered to do it, but it actually works really well in this scenario. So who's familiar with when I say weak blocks, kind of what that means at a high level? All right, so I'll go through it really quick. So weak blocks is an old idea, super old idea for how to do better block propagation in the peer-to-peer network, using a similar observation as pools use for shares. You can say, okay, the peer-to-peer network won't only send around full difficulty blocks, it'll actually send around what look like shares that are slightly reduced difficulty blocks. These blocks won't be like validated, won't be connected to the chain, but if we've already seen most of the transactions that come through in one of these lower difficulty blocks, then we can use a differential compression for the later, for the real full blocks that have many similar transactions. Of course, compact blocks and other schemes are more efficient than this, so this doesn't actually exist in an implemented form as far as I'm aware, but it makes a lot of sense here because we already have these shares, so we already have this kind of natural place to shim in weak blocks, because we're already sending from the client to the pool the shares, and we can just have a second kind of share difficulty that's slightly higher where we send the full block data, so all the transaction data as well instead of just the Merkle path. So we do that, and that uses obviously differential compression to say like, hey, that last weak block I sent you, take these transactions from it and here's some new transactions. And that works pretty well. The pool can select different difficulty tuning between the shares themselves and the weak blocks, so they can choose how much data they get from the client in that regard. And that allows them to spot check, right? So they can take those weak blocks that they receive, look at them, say like, yes, those transactions are valid. You're not mining Dogecoin on a Bitcoin pool. These like are well-formed things, and you're including transactions, and everything looks good. So we can pay you out. There's a little bit of complexity here. We'd like the pool to accept chain fork blocks, so not like Bitcoin Cash Bitcoin kind of forks, but if you have two blocks at the same height that are both valid, we don't want the pool to be involved in selecting which blocks you should be mining on, because that enables selfish mining attacks. And if we make that up to the clients, that means the client would have to do the selfish mining attack and not the pool. So ideally that's on the client end, but that obviously has complexity because you can't just take a random block you see and validate it steady state. You have to like build the UTXO for the previous block. So if you have a Bitcoin node, you have to you have to have some way to not validate it in that case. I don't actually really have a solution to that. I just know that that's rare enough that hopefully you're fine. And in practice, those are super rare, and as long as you are, again, because this is spot checking, right, you're not checking every share that comes in fully, that's probably okay. Your biggest goal here is to identify a misconfigured client, not necessarily a malicious client. Malicious clients can already exist today in Stratum. This doesn't change anything. BetterHash doesn't change anything in that regard. A malicious client in Stratum today can do block withholding attacks where they send you shares, but not if that share is going to actually be a full Bitcoin block, because they know that, and that just means the pool loses money but still pays you out. That doesn't change, so again, malicious miners, it's the same threat model that you have today, but a misconfigured miner is obviously a whole hell of a lot worse in BetterHash than in Stratum today. So that's kind of the reason for the weak blocks, and so we can fudge it a little bit and say, well, you know, it's okay that we don't necessarily have the ability to spot check everything. We can at least see that it's built on a block of the right height at the tip, at a potential tip that might be valid, and we'll go ahead and accept that.
Matt, can you do a short detour on why block withholding attack is useful against your own pool?
Against your own pool?
Well, that's what you were describing, right?
So no, I mean against a competitor. You do it against a competitor. So yeah, that's a good point though, actually. So there's a few. Who's familiar with payout schemes for pools? Yeah, this is a quick detour in algebra. So well. We can get into that in the Q&A if you're interested. There's fun attacks in early payout schemes, but because a lot of mining farms are operated by people who don't necessarily know very much about Bitcoin, they kind of naively assume that, or maybe rightfully so, assume that if the pool doesn't pay them out the exact same amount every day or every hour, that the pool is scamming them. And so if you have variance, right, the pool has some variance, and sometimes gets more blocks, sometimes gets less blocks, and just pays out based on how many blocks they get, you'll have a slightly different payout every day. So for just practical business reasons, they do, or most pools, especially in the Chinese market, use what's called pay per share, which means they pay out the expected value of a share every time they receive a share, irrespective of whether or not they actually mine a block. So if the pool hasn't found a block in a long time, they might go bankrupt because they're still paying out based on this. And so this makes block withholding attacks very nasty, because if a pool is charging a 5% fee and you have 5% of the hash rate of that pool, or 6% of the hash rate of that pool, you can make them go bankrupt with high probability, or eventually with high probability. Because you just do block withholding, they lose 6% of their income, they still pay you out 99.9% of what they're supposed to pay you, or what they would pay you if you weren't doing this attack, and they don't get the blocks, so you put them out of business. Why this attack doesn't happen in practice, I don't understand. I guess everyone is just kind of fine with it. And in practice, most pools, especially in the Chinese market, know their customers. What you would see if this attack started happening, I imagine, is just they would KYC their customers. But yeah, I don't know. I mean, you'd think it's kind of a cutthroat industry and you want to put your competitors out of business, but I guess not. I don't know. Yeah, I guess it's China. Who knows?
Well, you own all your competitors. That works as well.
Yeah, I guess if you are your own competitor, you don't really want to. Doesn't help. Yeah. So did that answer your question?
So there's no way of detecting when.
Not materially, no, because like blocks are rare enough. You don't have enough information to like do any kind of statistical analysis to see when your clients are doing a block withholding attack, unless that client is like really large, but that's not that common.
You can just make a probabilistic judgment that they are withholding blocks if they don't.
Yeah, but only if like they've been doing it for 6 months and like they very clearly should have found a block. Like there's not really enough information. I have actually heard a case of an accidental block withholding attack. It was detected because they weren't doing the block withholding attack like at the real Bitcoin difficulty, but at a much lower difficulty. So there was like this weird distribution of the difficulty of the shares coming from that miner. And they were able to identify, just because of a software bug in the mining, in the miners. Again, if there's a way to fuck it up, your users will find a way to do it. So.
You send the user like a prepared, like, I know that if you like use this second nonce, blah blah, and you will have to like run internally through like the main nonce, and like you should find a block because I give you already like a solved block. Like,
well, if you have a
username in there that doesn't work.
Yeah, if you have like per user data that doesn't work, and of course the user could detect, like you want them to be doing useful work because otherwise you're wasting money.
Like
in theory, like
testing, like.
Well, I mean that only works if it is a full Bitcoin block. So you'd only be able to do it like right when you find a block. You could send that same work to all other clients and make sure they get back to you with something. But you know, the user could like detect you doing this. Like if you want to go down the rabbit hole of a user being truly malicious and competent, they could, you know. Yeah. So chickens and eggs. Like getting adoption for something like this Pool doesn't want to run parallel infrastructure. They don't want to have like their existing stratum set up and also a whole second pool server without a lot of customer demand. But of course, the customers aren't going to demand something that A, doesn't make them more money, and B, the pool doesn't even offer. So how do you solve chicken and egg problems in terms of protocol adoption? I am all ears if you have ideas. Working on that one. It's slow going, but
Simulator?
yeah. So if you're writing a new pool, actually, I guess I'm done with the slide. Anyway, this has a implementation of the work and pool protocols. It has a sample pool, and it will speak Stratum on the back end to connect to existing clients. So like an existing miner obviously only speaks Stratum, and this will work for that. So if you're running a new pool, the anticipated layout is that you would use this software on the pool end, and then also run your own mining proxies that speak Stratum for clients who want to use Stratum, and then clients who want to use BetterHash can run their own mining proxy as well. So you kind of provide that mining proxy as an option for clients.
What are the constraints for running a mining pool? Because obviously when you run physical miners yourself, you're constrained by electricity and bandwidth.
The only real constraint is that you have enough clients. You have to have enough clients to have a steady payout stream, or steady blocks found, right? You can't necessarily, or enough hash rate in total, right? You can't necessarily run a pool if you have 0.1% of the network hash rate, because you won't really be solving the variance problem for your clients. They might as well just solo mine.
Yeah. But does geographical proximity to the clients matter much?
For block propagation, so in current pool design, yes. I guess I forgot to mention that. That was supposed to be on the other slide. But BetterHash actually kind of helps with that because of this weak block thing. So pools don't want to like throw away all of their existing block propagation tuning that they've done, especially in the paper share model, because in the paper share model, any orphan rate comes directly out of the pool's fee and not out of the clients, which it comes out of the clients in paper last end share or any of the sane payout schemes. So they don't want to throw away all of their block propagation work, and so that's another reason for the weak block stuff, is that the pool gets the full block relatively quickly when a block is found, which means they can do block propagation with that, but also the client can do it, right? So now if the pool server is further away, you might have a higher stale rate on your work submissions, but the client can do block propagation redundantly with the pool. And obviously that's only purely additive, that's only a gain, but now the like latency between you and the pool for block propagation isn't as big a concern because you can propagate it locally and then the pool can do it on the other side of the world and it's fine. So this started as kind of demoware. It's actually not that far off. There are some issues filed on it that are tagged MVP. If you want to help and you want to write stuff in Rust and you're interested in Rust or whatever, contributors are welcome to that. There's some stuff that's just not done yet, not implemented yet, some features that need to be added before it's kind of usable, but there's information there. There's 3 Bitcoin Core patches that I need to land upstream. You need to be able to submit headers and validate headers, loose headers, right? So I talked about how ideally if the miner, or if one of your clients as a pool is mining on some fork that's at the same block height as you want to be able to say like, yes, they are mining on a fork, it's the same block height, this is rare enough, this is okay, I'm gonna accept this. But in order for you to be able to do that, you have to have the header for the previous block that they're mining on. So they actually send you the header in the protocol. It's just an extra 80 bytes, so it's not very expensive. But that needs upstream support in Bitcoin Core. I think that might have actually already landed. Because I told Marco to do it, and I think he did it, and I think that might have landed. I don't know, I haven't been following that.
It's easy to live in a bubble when it comes to Bitcoin Core because you're always kind of following the subset of pull requests and
yeah.
the blinking blue dot of GitHub says there's something there, but you don't see half the rest of the repos.
Yeah, exactly. So I think that one might actually exist, but it needs to be plumbed through into the mining proxy code. Also need the support for validating the blocks themselves, so testing the block validity of a weak block that you receive from the client. That also needs to be plumbed through in the mining proxy and I think landed upstream. But there needs to be some tuning there to say, like, you know, if you have spare CPU cycles, you should be validating someone's weak blocks. But if you don't have spare CPU cycles, you should turn up their difficulty so that they submit fewer of them. So that needs some clever tuning there. It's a practical, fun project if someone feels like writing that. And then the work protocol itself, again, has to exist in Bitcoin Core. I have an experimental patch set for that. It's linked to from the README of this, and it has successfully mined testnet blocks before, so it kind of probably works, and again, just needs to land upstream. Yeah, so I was told I have to mention that we are running another residency this summer. Chaincode is. It's free, and I think we might help with housing if you need financial support, I think. Don't quote me on that. But it is going to be, this time it's going to be like a full summer. It's going to be 2 to 3 weeks of kind of course stuff and all kinds of fun philosophy of Bitcoin Core and details and implementation and all kinds of fun talks like this, except for 2 to 3 weeks solid, just a stupid amount of learning. And then like 2 months-ish, depending on your schedule, of project time, hands-on, with great mentors. You can apply at residency.chaincode.com. Don't wait, we're doing rolling admissions, so you screw yourself if you wait too long. And of course, if you so choose and you get accepted, your project time can be on BetterHash, so you could work on this with me in New York. So with that, any questions? All right, so I saw this one first.
Are there like major pools interested in this already?
So I've gotten some level of interest from folks. I've gotten like the BIP reviewed by some of the pool operators, and they provided good feedback. There's actually a few more changes I need to make in response to feedback that I got recently. You know, there's kind of the chicken and egg problem that I mentioned and also the like running a second set of infrastructure. So it's a little bit harder to justify that to an existing pool. There are some folks who are talking about building new pools based on this software. It's kind of nice because a lot of the pool software I have written for you and you can just use it. You just have to build like the website and fancy graphs and sparkly things, and I don't know what the fuck people do in UI. You know, obviously, like, you know, the slush pool people are excited about the concept, and I think there's Jan, the CEO of slush pool, was saying this on stage in Vegas a week ago. It's like, this is cool, and they support it in theory, but like it's hard to justify without customer demand, right? Like if there were a bunch of customers banging on their doors saying, hi, I want to use your pool, but I want to run my own full node, maybe they'd be more likely to do it. So you should totally go form a Twitter mob and tag at @slush_pool, I think it is. But it's hard to justify. So it's one of those kind of slow burn things.
Can the previous protocol be deprecated?
Can the previous protocol be what, sorry? Deprecated. I mean, ideally, eventually, but you have to get the hardware to upgrade because all the hardware supports Stratum and only supports Stratum. So that's a lot of kind of roll time.
So the main path to adoption really is like a miner, you basically have to get your pool on board, or like...
Yeah, or you can run your own pool, or you could solo mine using it if you are sufficiently large that you could solo mine. But yeah, there's folks talking about starting a pool. So it's, you know, this is one of those things that's kind of like a build it and then wait a few years and hopefully they will come. It's kind of intended to be a slow burn. I don't anticipate seeing material adoption of it in any short timeline, but hopefully with enough continued pressure, and if someone wants to finish the bugs that need to be implemented, then we can make that happen. But,
so there are people interested in making a new pool?
Yeah, I mean, you know, there's always people. It's not a terrible business to be in, so there's always people interested in getting in, I guess.
So there is an incentive there from the miner clients to run their own full nodes, that if the pool goes down, they can carry on mining.
Yeah. Well, I mean, most of them are already configured with multiple pools. So if one pool goes down, they can carry on mining on a different pool. Yeah, it's one of those things that's like kind of hard to justify this to anyone involved because no one makes more money necessarily. You can make some argument about how this looks better to investors of Bitcoin than the other chart. And so it's going to cause the Bitcoin price to pump. And so we should get this adopted now. But the market seems to be pretty irrational. So I don't know how strong an argument that is. But
how do you... So you prove to the pool that you paid to the pool
mm-hmm.
in the Coinbase, but you can lie about like where you find your precious transactions which pay like gajillions of transaction fees which actually never existed.
Yeah, you have to handle that.
But like proportionally to that.
Yeah. So you could totally claim in a share like, hi, I have 1 million Bitcoin in transaction fees. You should pay me out more because of that. You have to handle that on the payout side. So the BIP, I think, if not, I should go write it because I intended to, tells you your payout should not exceed the median fee claimed by your users. That makes it safe. Obviously, you have to spot check the weak blocks. If you spot check the weak blocks, you can detect a user who's cheating and ban them. And then as long as you don't pay out in excess of the median fee claimed by your users, you're never going to pay out too much. You just might be paying out to what is effectively a block withholding attack.
Are there any scenarios where a security vulnerability in the old protocol could cause mass adoption of BetterHash?
Yeah, these pools can like lose all their fucking hash rate overnight. Like if someone has a unfiltered BGP connection, you can get those in Eastern Europe all over the place, I hear, and wants to make some easy money, go BGP hijack some Bitcoin pools, and you will also drive adoption of BetterHash. I didn't just say that.
Wait till the BetterHash pool is ready before doing.
Yeah, please wait until there exists a BetterHash pool before you.
It goes along with Eric Voskuil's like general thesis that decentralization is a result of like attacks. So like if governments attack mining pools, I don't know, stuff like that.
Yeah.
Have you given any thought to paying out shares with Lightning? And does this make that remotely easier?
No, it doesn't really change it. So payouts are orthogonal and in fact not implemented in the sample client I have.
Is there a way to do that in a trustless way? Because that would be kind of cool. Yeah, like somehow the shares already open a Lightning channel or somehow push things inside a channel. I have no idea.
Intuitively, my answer is no. I haven't spent much time thinking about it. Bob McElrath has some designs around like fancier P2 pool. That he claims does it. I'm intuitively skeptical, but I haven't thought about it, so maybe it works. I don't know, talk to Bob. Or go read his post, I guess.
It could be some self-referential thing, or maybe it's Lightning-esque, where whatever you're doing in the Lightning channel points back to the hash of the block that you're doing it in, or the other way around. But
maybe? I don't know.
The Coinbase includes a pre-image, so the only way for the pool to get its money is to reveal this pre-image, and that also unlocks like the HTTP.
Yeah, but then how does that split everything?
Yeah, but but the pool, that only works when the pool finds a full block and broadcasts it. They don't have to reveal 99.99% of shares because they're not full blocks.
Yeah, so it's intended for P2 pool.
Yeah, okay, yeah. Yeah, because his scheme is like a P2 pool variant with like Ghost Spectre kind of design.
But I guess all the payouts could be a Merkle tree of pre-images of individual Lightning payments that pay all the participants somehow.
Maybe? No, because the problem is you're trying to reveal them and publish them. That'd be a lot of data to publish.
Yeah, I don't know how it actually works. So.
Yeah, anyway.
It'd be nice because it kind of solves a lot of these gaming problems. If you know for sure that every individual thing that you're sending to the pool is self-contained. And doesn't have to think about who to pay how much and smoothing things out.
Yeah, well, I mean, that's like, Bob's design is no longer has a centralized pool involved, so it's a little bit, I mean, it's back to the P2 pool design, right, which is a little bit more self-contained. Yeah.
I just wanted to correct, Bob didn't come up with this, it was me.
Oh, sorry. I'm sorry. It was not Bob's idea then.
Maybe you can explain P2 pool.
Yeah, that's Chris, but just speaking.
Yeah.
Yeah. Chris, do you want to explain P2 pool?
Well, P2 pool works in that you have a...
Here, let me give you this.
Yeah.
If you want to be on video, or on, wait, this isn't my shirt. On audio, at least.
Right, well, P2 pool works that these shares form like a share chain. And every node in P2 pool verifies this share chain and makes sure it pays out to the right people. And then when a real block is found, the hashers get paid in proportion to how much work they've contributed to the share pool. To the share chain. And you could make it trustless so that they can't cheat each other. That's a summary really of how it works. But it's dead, like there's loads of problems with it, unfortunately.
I mean, its biggest problem was just it was bad UX, because it reported a higher stale rate because it had like this low inner block time, and so you had naturally high stale rates, but the payouts what mattered for the payouts, like for a centralized pool, if you have a stale rate, you miss that many payouts. In P2 pool, if you have a stale rate, you can still get payouts for stale shares. You just, the only thing that matters is your stale rate in comparison to other clients. And so you had a lot of miners who were running P2 pool, and it said like, hey, you have a 2% stale rate. And they were like, fuck this. My centralized pool says I have 0.1% stale rate. I'm not going to use P2 pool. And so P2 pool died for no reason because it had bad UX.
But it doesn't solve P2 pool most of these problems. Like, couldn't we end up with this image P2 pool?
Yeah, so a P2 pool solves this problem. I mean, P2 pool has a lot of complexity. So kind of the intention of BetterHash is like, well, we can do effectively as well as P2 pool. You still trust the pools for payouts, but hopefully they're only able to rip you off for a day and then you can go somewhere else. But we can do almost as good as P2 pool without all of the complexity of a share chain and all of whatever. And this is like 2 orders of magnitude easier to implement and maintain than P2 pool. And that goes a long way in terms of adoption, I think. But I'd be happy to be wrong. I'd be happy if P2 pool took off again and everyone just used that instead of this. But
wasn't another factor with P2 pool from my memory of using it was that you had to have a full node, which is for a lot of people, when you're mining, having a full node is an issue.
Yeah, totally. I mean, like,
everybody should have their own full node, but
yeah, totally. P2 pool made you have a full node, whereas at least this is like optional, have a full node. And yeah, I mean, I anticipate that most people using BetterHash kind of pools won't run their own full node. My hope is that you can move to a world where it is really easy. You just like buy a Casa HODL style node, you plug it in, and now you're running a full node. And you can have at least some of the larger clients of pools do that, which will get you most of the advantage here, even if like all the small clients are just on pools, that's okay.
This is one of the big issues with pool also, that you have like these tiny payouts, and then you have like a gajillion of them before you can form like a meaningful output. While in a centralized pool, you can like set a payout threshold, which here you kind of cannot.
So BetterHash doesn't really affect payouts in any material way. In fact, the software I have literally, like, it just has a hook for like, hi, I received a share from this client, and it's up to someone building a pool to implement the database tracking and all of that stuff, and actually do the payout stuff. And then that's no different from today versus this. You just still have that same kind of like, I got a share from client A for value B.
I was talking about P2 pool.
Oh, P2 pool, yeah, P2 pool. Yeah, another problem, yeah, P2 pool had very high payout thresholds because they were all on-chain, and they ended up with like these huge Coinbase transactions. I guess another problem with P2 pool is they had these big Coinbase transactions, and some of the early ASICs actually barfed if you gave them too large a Coinbase transaction and like couldn't mine with it, because you have to pass the ASIC, the Coinbase transaction itself, in Stratum, and that they had some limit in their JSON parser because like, hey, parsing JSON in embedded devices is hard. Who would have guessed? Yeah. So P2Pool, I mean, it just like also like Thomas walked away from it and wasn't really maintaining it. Or not Tom, Forrest V. Yeah. He like went and did a rocket science PhD or something and got bored with P2Pool. So I think it's kind of unmaintained. If someone wants to maintain it, go for it. But
it's really hard to read. Like it's massive Python files that are really hard.
Oh, well, okay. Someone could rewrite P2Pool and then maintain it.
So some questions from Twitter. I think you've answered a couple of them. One is from Dan Kuhl. He says, does BetterHash allow overt ASIC boosts?
Yeah. So it is explicit in the BetterHash spec that overt ASIC boost is allowed, and specifically because the 2 bytes in the version field that I mentioned are explicitly allowed to be tweaked in any way you'd like. That's compatible with existing ASIC boost stuff, which just uses 2 bits and also gives you spare room to not need the extra nonce in the Coinbase.
Cool. And BTC Pat says, again, you've probably asked this, why isn't there a BetterHash pool already available? Can BetterHash and Stratum coexist? And what's the ideas for BetterHash adoption?
I think that's pretty well answered. Yeah, the question was about adoption and Stratum coexistence, but I think we covered that one.
Any other questions on Stratum?
Why weren't the 2 bytes of the version field not used before? Like, why do we go all this detour over the Coinbase in the first place?
The question is why didn't like early Stratum specify that the 2 bytes in the version field are free for extra non-space? I mean, it's bad form to just be like, this thing that has consensus rules around it, we're gonna like embed it in the ASICs that they can change this. Because then you might have like a soft fork or something that breaks your ASICs just because someone wants to increase the version number. Again, because, like if we all agree that we can take 2 bytes of the version field and apply no consensus meaning to them forevermore, it's completely fine to do this. At this point, because of ASIC boost, we already are kind of locked into that. We can't do anything about it, at least without breaking all of the ASIC boost miners, which we don't necessarily want to do. So just because it's kind of bad form, I guess.
So so it's 4 bytes, right? There are 32-bit integers. Yeah, these
version, yeah. They're all 32-bit integers, yeah.
I guess that's just the way it is. It's just we use 32-bit integers. That's
because Satoshi, you know. I mean, they're also like little endian 32-bit. It's weird.
Yeah. So a couple of questions from me. One, I was quite surprised when I learned that a lot of the Bitcoin exchanges don't rely much on Bitcoin Core software. And I was just as surprised also to read that miners do heavily rely on Bitcoin Core software. Like,
yeah, so I think...
Is that true impression?
Yeah, I mean, I actually don't think most exchangers don't rely on Bitcoin Core. I think that by far, in a way, the most common setup for an exchange is you have like Bitcoin Core nodes that you run, and then you have your own internal SPV node using, Bitcoin.js or Bitcoin.j or whatever, and then that connects only to your own Bitcoin Core nodes. So in a sense, you're still relying on Bitcoin Core. That's still, you won't get data from anything else except your own full node that you're running, but you don't have any of your business logic in Bitcoin Core. And in a sense, the pool setup is actually kind of similar in that most of your business logic is on the pool server and you have most of the, all the logic around payout and share validation and everything is on the pool server end, and you're just using Bitcoin Core to get data about new blocks. You use it a little bit more, obviously, than just making a peer-to-peer connection to it, but it's still, and then there's not, to my knowledge, any real alternatives in terms of, if you want good performance for Git block template, I don't even know if anything is re-implemented Git block template in its insanity.
I've never even looked at it.
I don't think anyone else does either. It has a bunch of bells and whistles that I'm pretty sure are documented in the Git block template spec and aren't even implemented. And I know that none of the things that it has, aside from just the really basic give me a block template version, are implemented in any of the pools. Like, it has bells and whistles, but it's just, no one cares because it's gratuitously inefficient and over-designed.
Will have much better latency with this regard and just
yeah. So that's
profitable.
Yeah, so that's the other reason to pull git block template out and into like a binary protocol that's just push specifically, right? So in the BetterHash work protocol, you have like if Bitcoin Core gets a new block, it pushes that information to the pool server or to the clients, whereas git block template is polling. No, it's a raw TCP socket. You just connect and it'll give you new work. So in practice, it'll be a little bit lower latency, not enough to make a difference for profitability, or at least not materially. But only because most of the pool servers are like heavily optimized for making sure that right when Bitcoin Core gets a new block, it does a git block template request. And it like, they do stupid crap like connect to the TCP, like connect to the peer-to-peer port to get a push notification of a new block so that they can then go request git block templates. Like, yeah. But yeah, without the like JSON round trip and stuff, it'll be a little bit faster. So you could make some argument about better profitability, but not a very strong one.
It said in your bit, like there's widespread reliance upon Bitcoin Core APIs. Are you familiar with?
That's the reference to git block template.
Yes.
There's widespread reliance on this. Oh, sorry. Yeah, that's actually a reference to like, so because most of these pool servers are like optimized for latency and they care a lot about the latency, they like do these stupid hacks where if we change something about like the way we send notifications of new blocks to our peer-to-peer connections, then we might break pool servers because they're using that as a notification to some other subpart of the daemon. And it's just like this weird dependence that we might accidentally break because we go optimize something else and like, oops, now all the pool servers are broken for complete nonsense reasons. We don't want to be in that state.
Their architecture to be properly like the proper boundary between what they see as their sort of service.
Yeah.
Bitcoin Core as a service to them.
Yeah.
Like you said with exchanges, the same thing, right? They've got Core out there. They could, in theory, swap it out.
Yeah. And I mean, it does. Yeah. So that's the other, like, at least BetterHash is like better documented, and you still get that boundary, and it's like just in this case, it's like, here's one protocol, you use this, not like you connect over ZMQ and the peer-to-peer, and it's like, you have your little potato computer here and you like shove electrodes on both sides so that you can get something out of them. It's like, what?
When your disk space decreases by more than 1 megabyte.
Call git block template. Yeah.
So why would you subscribe to the blocks and then connect to the PTP interface on the same server? That makes sense.
Yeah, because the git block template doesn't give you like a push notification when you get a new block. So you have to connect via the peer-to-peer interface to get a push notification so that you can go pull git block template. And they often will, and then I think they also support ZMQ to get the push notification, but
so
yeah.
I did that twice, one from the P2P and one from ZMQ.
Yeah, because one might come first, and like one will come first. It's random which one, because like Bitcoin Core is not designed to support like 1 millisecond push notifications over arbitrary interfaces. Like, no. But we can do that if like we're using a protocol that explicitly supports it. We can go optimize that in Bitcoin Core, and it's like a first-class supported feature versus this weird like hacks that people do that we might break without realizing it very easily.
How you come up with the hash rate distribution? It's completely random, or yes?
This is actual data though. This is the slush pool. I took the breakdown of the slush pool. So they have public, like user A has 1% of their hash rate and user B has 0.5% and whatever, and I plugged it all into Excel. And so this is actually like, you can see where the big chunks are. That's like, this is ant pool and that's btc.com and whatever. And then the actual breakdown of the individual bars are based on slush pool distribution of the distribution of hash rate within their users. So that's at least valid for slush pool. I think the distribution will be different on like Antpool and BTC.com, but It's
assuming that each pool is the same as such pool.
Yeah, assuming each pool has the same distribution of hash rate, then that would be valid. It's a strong assumption, but it's like not completely far off.
Sorry, one more. There's an old sort of theory in Bitcoin. It's, we're going to have commodity hardware, we're going to have miners and toasters. What's
and cable boxes.
Several years later, after the first time people started saying that, what do you feel?
I don't know. It seems like 21 had to pivot, so seems like it didn't work. That was a few years ago.
Were they crazy, or were they just ahead of their time?
Well, most of that is termed in the we're going to use them as heaters. And remember that an electric heater is a hell of a lot less efficient than a heat pump. So if you care about the efficiency of your heating, you're not going to use an ASIC. If you have an existing electric heater, you might replace it with an ASIC, but it's not. It seems weird that would be competitive commercially, especially since cheap power is in a few specific locations that have hydro, that have cheap green energy, and not.
So it's more about energy distribution than it is about the fact that hardware reaches a certain physical limit in terms of efficiency.
Well, we're kind of at the point for hardware, and that's why you see more competition in that market, which is really exciting. But my sense has always been that distribution of hash power is more about the power markets than distribution of the hardware itself. Now, luckily, the power markets are pretty distributed. It turns out you can go buy a small amount of cheap hydropower a whole hell of a lot easier than you can show up and buy 100 megawatts or 200 megawatts of cheap hydropower. So it actually has some.
Pretty expensive generally. So.
What? Consumer electricity is stupid expensive, yeah.
Yeah, and so then unless you have a number of giant solar panels, but that just doesn't add up enough for money.
Yeah.
So unless you have a windmill in your own garden, that's.
Some people have windmills. I don't know.
So you joked about man-in-the-middle attacks and hijacking BGP, but has anybody actually seriously considered mechanisms to disincentivize pooled mining?
So yeah, I mean, there's been some attempts to disincentivize pooled mining. The term you're looking for in a Google search is what's the term?
Non-outsourceable puzzle.
Thank you. Non-outsourceable proof of work, non-outsourceable puzzle. I'm skeptical. So the idea of non-outsourceable puzzle is that you design it such that if the client of the pool is able to detect whether or not this meets the full block difficulty, then they can steal the full reward. Or so just generally, if you allow the client to steal the reward, right? So you design it such that the pool will never be able to trust the clients because if the block is actually a full valid block, the client will just steal all of the reward for the block and the pool won't get the reward, so pools would be broken. I'm vaguely dubious of this because, as we discussed, you could already put all of your competition out of business with block withholding attacks, and this doesn't happen, so it seems weird that a technical solution will solve this. Again, you'll just have pools that like KYC, right?
The cost difference is significantly different. Any one of the miners in the pool could steal.
No, it would have to be the miner who found the block can steal that block's reward. And you just end up in a world where you KYC them and you are fine. The problem, so the real thing with pools is if you solve the problem is also the reward variance, right? If you make the variance really low, you have less incentive for pools to exist. But you might still have pool, you still see pools in Ethereum, but the reason you see pools in Ethereum is because they take over running a full node for you, which is a lot of effort, and especially in Ethereum, it's really hard. Whereas there's there's lower inner block time, so there is much lower variance, but even still you see pools, right?
But up to a certain size, I would say pools are positive, right? Because they allow much smaller organizations to mine.
Yeah, there's nothing inherently wrong with pools. They very neatly solve the payout distribution, which is really nice. If we could get them to use BetterHash, then they could rip off their miners and try to hold them hostage, but the miners can go elsewhere pretty easily, so.
What are you talk about at the conference?
So on Thursday, I'm going to be talking about Rust Lightning, which is a project I've been working on to implement, it's a batteries not included Lightning node. So LND, C Lightning, these things are kind of a full standalone Lightning node where they have a wallet, they download the blockchain, they scan the blockchain, they do all of these things. If you are, for example, an existing wallet, you already are, Electrum or Mycelium or whatever, taking a full Lightning implementation in a node and like, how do you use that? How do you integrate that? You don't just like run a second wallet in your wallet. That's kind of nonsense. So Rust Lightning is all of the pieces of Lightning implemented for you, except for like the last step of downloading the chain and generating keys and storing things on disk and these kinds of things. So there's some cool stuff that I've been doing with it in terms of like fuzzing the actual protocol logic and finding bugs in much cleverer ways than almost kind of any other existing fuzz work that I've seen. That I'll be talking about in addition to kind of the high-level API and what you can do with it and how you might integrate it into a mobile wallet or how you might integrate it into a hardware wallet or all kinds of fun stuff.
It's aiming to be really, really flexible in comparison to some of those alternatives.
Yeah, so like, if you want to run a Lightning daemon, I would not suggest you take Rust Lightning. I would suggest you go take LND. I don't intend to compete with that. It's more a very flexible thing that you can integrate into a lot of different ways. So you might imagine having it synced across different devices, having hardware modules that are mutually distrusting, that are like partially offline, and integrating it in that way. So it's designed to support these kinds of different use cases that kind of current Lightning stuff just doesn't have a concept for.
Are you following those other implementations closely?
Not that closely. I don't have strong views of them.
Okay. I've had an interesting Twitter conversation between you and Alex Bosworth on some of the design decisions for C Lightning and LND versus Rust Lightning.
Yeah, I don't remember. Yeah.
One more question about hashing again. So apart from the pooling problem, are you not concerned about mining centralization then?
I'm not really. I guess Eric Voskuil's not here, but he likes to complain about BetterHash. And he has a valid argument. Like his point is essentially that like if you are beholden to your pool, they could tell you, hi, you have to now run Bitcoin Core patch to censor these transactions or we're not going to pay you. So, there's still some effective centralization there. I'm personally not at all concerned about that because like if your pool says, hi, currently today the pool can just do this and you don't even notice. Like you would have to spend a lot of effort to detect this. Whereas in a BetterHash world, it's like, yes, hi, you have to take active action to apply this patch and run this version of Bitcoin Core instead. And like, it's much easier for your response to that to just switch to a different pool than actually do what they tell you to do. So you don't really care. I'm not too worried about that. Sure, if you have like only one pool, you might still have that problem. But of course, if you only have one pool and they do this, you can go create a pool. So I don't know.
No, I mean, rather from a manufacturing point of view, or like.
Oh, from a manufacturing point of view, yeah, that's completely orthogonal ASIC manufacturing. But luckily, that's improving a lot because we're getting to the kind of current gen process for semiconductors. So that's become much more distributed, which is nice.
And you're removing the need to parse JSON, which means.
Yeah, and we can simplify the fucking controllers so they're not running like weird CG miner hacks on hacks and parsing JSON and let's say spaghetti C code. Crazy. Okay.
Can you talk a little bit about Rust and how you're finding developing on it?
The other question was about Rust. I really like Rust. I mean, remember the Rust was designed in large part because Mozilla got tired of C++ being terrible in Firefox and having security bugs out the wazoo, and they wanted something that was efficient and much safer to replace it with. I found it to be really nice to use, but I was also coming from C++, so I was kind of the target audience. Generally, I'm a huge fan. I haven't messed around with like Go or any of the things that are seen as alternatives, but they're rather orthogonal. Like if you're going to do, especially embedded programming, like some of the stuff is intended for, especially Rust Lightning is intended for. Go doesn't really make sense. You have this big runtime and garbage collector and whatever, whereas Rust doesn't, which is nice for that kind of use case. But I found it to be great. It's still a little bit immature, so the BetterHash implementation I have is in Rust, but uses some of the newfangled Rust async stuff, which isn't kind of complete yet, and hopefully they'll kind of finish up in the next year or two. So it's still a newer language, especially for server development kind of stuff. But Rust Lightning is just a C callable library. So I have most of a C wrapper written for it, so you can like embed it anywhere C is, and Rust is relatively mature for that kind of application, where you're not doing anything fancy, you're just providing an API in a C callable wrapper. I found it to be pretty mature for that. So.
I just had one question that sort of rolled into a few more, but can you open a payment channel, like a Lightning channel, with a Coinbase transaction?
Yes.
Okay, and then does BetterHash sort of enable things like I, as a miner, have my full node, I can include transactions that like I actually want to send for like no fees or something like that, or like open channels like that?
Yes.
Okay, cool.
So yeah, if you wanted to open a Lightning channel, I mean, I want to mine my own transactions to avoid paying fee on it, you do pay the fee in opportunity cost. So, I mean, yeah, and you hurt your anonymity because it's clearly the miner who included this, and you're paying it in electricity fees. So, I mean, yeah.
But at least you know for sure you can close the channel.
That's true. Like, you know, well, if you have enough hash rate to mine a block in the correct amount of time, yeah.
There's a real impetus to decentralize mining with Lightning, right? As Lightning matures, Lightning's really dependent on miners not being able to sense transactions.
Yeah, in fact, kind of all second layer, almost all proposals for doing more scalable chains. So that's, you know, sidechain kind of designs, that's Lightning, that's, I mean, there's other stuff in that category, but they all, I think the key kind of assumption that they've all chosen to make is what I've been referring to is they elevate the censorship resistance assumption in Bitcoin to a security assumption instead of like a privacy assumption or a like utility assumption, right? We assume like, okay, fine, if you couldn't get your transaction through in Bitcoin and transactions were being censored, this is probably going to destroy the value of Bitcoin in the long run, but maybe this is okay on short bursts. Maybe this won't hurt Bitcoin materially if we can like re-decentralize mining and whatever. Whereas in a system like Lightning or a system like a proof of work secured sidechain or something like that, if this is violated temporarily, you not only have a broken user experience, but you actually lose money. So that's generally kind of the key design, and yeah, so as you point out, decentralizing mining is kind of an important part of that, at least in my opinion. So that was kind of some of the impetus to work on this, but also just, I mean, like we're currently in a very fucked state, so we should fix that.
It goes along with Schnorr, I would say, because Schnorr lets you kind of blend in these opening and closing transactions a bit more, so it's more difficult to see, oh, that's the Lightning channel close.
That's true, that's true.
With a forced close, you wouldn't have that.
Well,
you're still expressing the script.
Yeah, with a forced close, you wouldn't have that, and the like open is just a Batch32 output anyway. Yeah. So, I mean, the point was, or the comment for those on video is that because Schnorr might allow you to make or masked or whatever might allow you to make Lightning transactions look the same as any other transaction. Decentralizing mining is useful and kind of goes hand in hand with that because something. I don't know, whatever. It was a good point, but...
If you open it and you also use Taproot, then it would look like a normal transaction.
Yes, if you use Taproot, it would look like a normal transaction.
But the non-cooperative close.
Non-cooperative close still looks better. Does the L2 stuff? Yeah, I guess because it'll be like the only thing that uses op. What do you call it? Or the sig hash none. Yeah, sig hash no input. Sorry. Yeah. So I guess that'll still be obvious. Hopefully, the only thing that uses sig hash no input. Anything else uses sig hash no input, we might be fucked.
You didn't give it its full title.
Sig hash no input. Don't use this. This is dangerous. It will eat your babies. Yeah, babies are dying in Africa apparently. So.
Could you give a bit more detail on the fuzz test that you wrote for Rust Lightning? But perhaps explain what a fuzz test is first. And then
yeah. So for those who are unfamiliar, fuzz testing is a general testing approach of just black boxing a test case that takes as input some random set of bytes, running a program on it, and trying to make it crash. So this is primarily used for decoders, things like that. They've proven to be very, very, very effective at taking, like an image decompression library or something that processes untrusted data off a network and making it crash, finding vulnerabilities in it, finding stack overflow, buffer overflow kind of vulnerabilities. And they do this, they're not just completely dumb, like shove in random bytes. They actually instrument the binary. Usually what they do is they instrument the binary, and you can do this in hardware or in software, and detect when a given input has found new paths in the program, right? So you map out all the if statements and all the branches in the program, and if it finds an input that hits a new branch, then it considers that input interesting, and it will mutate that input a little bit more than other inputs. And they've actually had great results finding all kinds of fun security bugs in, again, mostly kind of image decompression, that kind of library. With Rust Lightning, because it's a library and it's kind of the C embeddable thing and it has no runtime associated with it, it's super easy to shove it in fuzz tests. And one thing that I've done recently that has turned out to be really cool and really useful, and to my knowledge, kind of the first use of this kind of approach to fuzzing, is it actually there's a fuzz test where it stands up multiple nodes in the same process, connects them to each other, and then interprets the fuzz input as a list of commands to do to these nodes, and then tries to make the nodes disagree about the current state of the channel. So these commands take the form of things like, please initiate sending a payment from this node to this node, or from different sets of nodes. And it can also deliver messages out of order. So it can, the fuzz tester can actually kind of hit speed of light issues in terms of messages sent and getting delivered at different times. And then its goal is to say, if somehow it can make the nodes disagree about the state of the channel, then this is considered a crash and this is bad. This has found a number of really weird corner case bugs of if you do these 4 things in exactly this order, then it forgets to set this flag, when then that'll result in a disagreement if these other 4 things happen in this order. So the Lightning channel state machine is actually not as simple as it sounds. It's rather complicated. So it's been a very effective test at fuzzing the Rust Lightning channel state machine. Yeah.
Any other questions? No? Okay, well, thanks, Matt, for
cool.
coming and speaking to us.